Hi, we are from Group 1 going to present our instrumentation project. This is our problem statement for this task. Basically, we are need to come out with line tracing for the process, which include identifying and listing down the mechanical equipment, valve, and as well as identifying the control loop symbols. This is our problem identification. We already know the PNID and control loops in the process, and also the configuration of control loops and the input-output variables. The learning issues are as a line tracing for the process and the selection of sensors, transmitters, and valves. This is a PNID of edible oils refining plant. Line tracing. So what is sensors? Sensors is used to measure a physical variable which produce a physical response that is related to the value of the process variable. Type of sensors in this PNID are pressure indicator, flow indicator, level indicator, flow indicator controller, level indicator controller, and temperature indicator controller. Basically, these sensors are discrete and they are field mounted. Control valves are used to regulate the flow and pressure and also the direction of flow within a piping system. The type of control valves are pneumatic gate valve and linear piston actuator. The transmission lines are used to connect between instruments or process to transmit signals. Transmission lines in this PNID are process flow line, impulse line, and the electrical signal line. The mechanical equipment is a device with a special or own purpose to do a specific job that related to movement of mechanism with the help of electricity power or human energy. Our mechanical equipment in this PNID are pump, flow meter, steam ejector, bag filter, cartridge filter, mixing tank, plate heat exchanger, high pressure boiler, barometric condenser, vessel, scrubber, and a bubble cap tray column.
Okay, moving on to the control concept table and justification of instruments chosen. The first control loop, we think that two pneumatic control valves installed in the vessels because we want to control the level of bleached oil entering the vessel. We want to control the level of bleached oil entering by manipulating the flow rate of bleached oil entering the vessel. The disturbances will be the flow rate of steam entering the vessel, and this is a feedback control system. And to measure the level among the level sensors such as float activated head devices, radar, and ultrasonic, we think the ultrasonic sensor is the best because it is a non-invasive technique immune to dust. Results can be obtained accurately in a very shorter period, and it is very cost effective, and it can solve most complicated work. And among the valves such as ball valve, butterfly valve, check valve, gate valve, globe valve, needle valve, and etc. We think pneumatic gate valve is the best because the range of applications is wide, fluid resistance of the valve is small, has dual flow directions, and it can flow with low pressure drop. Moving on to the second loop, we want to control the temperature of mixture leaving the HE712. We control the temperature of mixture leaving by manipulating the flow of steam entering 2HE712. The disturbances will be the temperature of mixture entering 2HE712, and it is a feedback control system. Among the temperature sensors such as resistance temperature detector, thermocouple, and thermistor, we think the best instrument will be resistance temperature detector because it is good stability, excellent accuracy, and it is resistant to contamination, good linearity. It is a very repeatable temperature measurement, and the area of temperature sensing is wide. And moving on, the type of valves. Among the type of valves such as ball valve, butterfly valve, check valve, gate valve, globe valve, and etc. We think the best will be pneumatic gate valve because the range of applications is wide, fluid resistance of the valve is small, has dual flow directions, and it can flow with low pressure drops. Moving on to the loop 3, we want to control the liquid in the bottom of bubble tray tower. We control the level of liquid in the bottom of bubble cap tray tower by manipulating the flow rate of liquid leaving the bubble cap tray tower and flowing into the 2HE711. The disturbances will be the flow rate of steam entering each tray of bubble cap tray tower, and it is a feedback control system. Thank you.
A very good afternoon. I am Tiba Dr. Gopal. Now let's see the justification on instrument chosen for loop 3. There are many types of level sensors and they are float activated heat devices, diaphragm and ultrasonic. So among the sensors, we have chosen diaphragm because it has mechanical and simple structure. It is easy to install. It has energy saving and economical. It doesn't require field calibration and it can be used for many liquids and is unaffected by dielectric constant. And for the type of valves, there are different types of valves. From among the valves, we have chosen pneumatic gate valve because it has a range of applications, which is why the fluid resistance of the valve is small. It has dual flow directions and it is full flow with low pressure drops. Now let's see for loop 4. So the control objective is controlling the temperature of mixture leaving heat exchanger, and the control variable is the temperature of leaving heat exchanger. And the control variable and the measure variable is the same, which is also the temperature of the mixture leaving 2HE751. The manipulated variable is the flow of cooling water entering 2HE751. The disturbances is the temperature of the mixture leaving the vessel. Since the control variable equals the measured variable, the control configuration is feedback control. Now let's see the justification on instrument chosen for loop 4. There are different types of sensors as you can see here, and the instrument chosen is the RTD, which is also known as resistance temperature detector. This is because it has good stability, excellent accuracy, contamination resistant, good linearity, area temperature sensing, and very repeatable temperature measurement. Among the type of valves, we have chosen pneumatic gate valve, and the reasons are just as we saw in loop 3. For loop 5, the control objective is the controlling the level of fatty acid oil in the bottom of the scrubber, and the control variable is the level of fatty acid oil in the bottom of the scrubber, and the measured variable is also the same, which is the level of fatty acid oil in the bottom of the scrubber. The manipulated variable is the flow rate of the fatty acid oil leaving the scrubber after the process becomes stable. The disturbances is the flow rate of fatty acid oil entering the scrubber at lower temperature. Since the control variable equals to measured variable, the control configuration is feedback control. So for the justification part, among the different types of level sensors, we have chosen diaphragm, and the justifications are just the same as we saw in loop 3. And for the types of valve, among the different types of valve, we have chosen pneumatic actuator because it is dependability and simplicity and has dependability and simplicity of design. It is fast stroking speeds, low fire risk, lower cost, and pressurized air can be stored so that the valves can be operated when the power is lost. That's all from me. Thank you.
Assalamu alaikum and hello doctor. In this part I'm gonna present from loop 6 until the end. So for 2HE742 our control objective is controlling the temperature of mixture leaving 2HE742. The controlled variable and measured variable are the temperature of the mixture leaving 2HE742, and the manipulated variable is the flow of cooling water entering 2HE742. The disturbances is the temperature of the mixture from 2HE711, and the control configuration used here is feedback control. Moving to the next part, the justification on instrumentation choice. So types of temperature sensors we have considered here. You can see the instrument we have chosen resistance temperature detector, which is RTD, and the justifications are good stability, excellent accuracy, contamination resistant, good linearity, area temperature sensing, and very repeatable temperature measurement. And for the type of bulbs, you can see we have considered the type of bulbs here, and our instrument choice is pneumatic gate valve, and the justifications are range of applications is wide, has dual flow directions, fluid resistance of the valve is small, fluid flow with low pressure drops. For the loop 7, the control objective is controlling the level mixture in the bubble cap tray tower by manipulating the flow rate of a bleached oil from 2VE701A/B, and the control variable primary the level of mixture in the bubble cap tray tower, secondary the flow rate of bleached oil from 2VE701A/B, and the measured variable is same. The control configuration is here cascade control. So the justifications are our instrumentation choice is vortex shredding, and the justifications wide range ability, insensitive to variations in density, temperature, pressure, and viscosity. Types of level sensors, float activated head devices, radar and ultrasonic, and our choice is ultrasonic sensor. And the justifications, you can see it's a non-invasive technique that does not involve placing anything in the material. And you can see the others here. The important one is it's cost effective also. Moving to the next part, the types of valves you can see here. Types of valves you can see here: ball valve, butterfly valve, and so on. And our choice has been the pneumatic gate valve, and the justifications are same as we discussed previously. That's all from us. Thank you.